So dear friends, we discussed today what law? Kohlrausch law, or it is called as law of independent migration of the ions. Limiting, it is defined as, Kohlrausch law is defined as the limiting molar conductivity of electrolyte at infinite dilution is sum of the individual contribution of what? Cation and anion. When concentration approaches to zero, is called limiting molar conductivity. How can we express the electrolytic solution according to the Kohlrausch law of independent migration of ion? Let me take limiting molar conductivity at infinite dilution of NaCl equal to limiting molar conductivity of Na positive plus limiting molar conductivity of Cl negative. Limiting molar conductivity of CaCl2, that is limiting molar conductivity of calcium 2 positive plus limiting molar conductivity of 2 times Cl negative. Limiting molar conductivity of AlCl3 equal to limiting molar conductivity of Al3 positive plus 3 times limiting molar conductivity of chloride ion negative. Whatever the value given to calculate, for example, NaCl. If the value is given there, value must be given, data is given. If it is 100 Simon centimeter, 2 mole minus 1, or this is 100 plus 200, that is the 300, right? Now, for example, if this value of aluminum ion is 250 plus this is the 300, then the total is the 500 Simon centimeter to mole minus 1. Whatever the value given, just you add for two different electrolytes, and the way you can calculate CaCl2, NaCl, AlCl3 on the basis of that. The very important part is what are the application of the Kohlrausch law of independent migration of the ions. The first application of Kohlrausch law, first to get or to calculate the limiting molar conductivity of, what is that? Weak electrolyte. To get the weak electrolyte, we have to select the 3 strong electrolytes. Out of 3, 2 common ions are added and 3rd uncommon is subtracted. I give you one example from your textbook. How to calculate the limiting molar conductivity of, what is that? Water. So let you break the water first. Limiting molar conductivity of H positive plus limiting molar conductivity of, what is that? Yes friends, OH negative. So let you find first how to get the limiting molar conductivity of weak electrolyte. We have to select 3 different strong electrolytes. For a water molecule, we need H, so we take HCl. We need OH, so we take NaOH. And 3rd uncommon, that must be subtracted, NaCl. So therefore, we can take this one, like how to calculate this values. Limiting molar conductivity of NaOH plus limiting molar conductivity of HCl minus limiting molar conductivity of, what is that? NaCl. What is common? Na and Na. It is the minus, chlorine minus, and here chlorine plus. So what factors are still there? OH, and then what is there? H positive. That's why we get the limiting molar conductivity of water is equal to limiting molar conductivity of OH negative plus limiting molar conductivity of H positive. The unit is the Simon centimeter to mole minus 1. Whatever the values given, NaOH 200, HCl 300, and this value is NaCl 100. 200 plus 300 minus 100. The way you can calculate the limiting molar conductivity of weak electrolyte. For example, let you go for the acetic acid. I give you the another example. To get acetic acid, that is the CS3COOH, or it is written like this, acetic acid is the HAC is the modern language. There HAC is the acetic acid. So we can say, let you break fast. Molar conductivity of CS3COO negative plus molar conductivity of H positive. We need these two. Therefore, what we take? Solution is limiting molar conductivity of CS3COO Na plus limiting molar conductivity of HCl minus limiting molar conductivity of, what is that? NaCl. Na cancelled. Say Cl cancelled. So what is there now? See, so we get the acetic acid CS3COOH. The way you can calculate limiting molar conductivity of CS3COO negative plus H positive. This is one of the first application of the Kohlrausch law of independent migration of ions. There we go for the second one. What is the second application? Anyone? Second application is to calculate the degree of dissociation. It is the ratio between limiting molar conductivity at given concentration and limiting molar conductivity at infinite dilution. This one means molar conductivity at given concentration, and it is given at what? Infinite. What is that? Dilution. So the way you can calculate molar conductivity at infinite dilution, concentration is given to you. Thus we can get alpha. What is alpha? Alpha is the degree of dissociation. Third one is how to calculate the equilibrium constant. So this is what it is, the let see, so equilibrium constant we have to calculate, and then see let's friends here, equilibrium constant, let AB is the electrolyte, A positive and B negative. Let C is the concentration of AB at time 0, so product is 0. C minus C alpha and C alpha. At equilibrium, C alpha into C alpha upon 1 minus alpha, or C square alpha square C 1 minus alpha. Right now, so what is that? This is the cancelled out. So C into alpha square 1 minus alpha at infinite dilution. So K you can calculate C into alpha square upon 1 minus alpha. So how many applications of the Kohlrausch law of independent migration of the ion? There are 3 applications of the Kohlrausch law. First we get the limiting molar conductivity of weak electrolyte. For that we take 3 strong electrolyte, 2 common ions are added, and third one is subtracted. I have solved a question from textbook how to calculate the limiting molar conductivity of water. Second, alpha is the degree of dissociation, that is the ratio between molar concentration at given molar conductivity at given concentration upon at infinite dilution. Once you calculate the equilibrium constant, the way C square alpha square, C into alpha square upon 1 minus alpha. In my next class, we will discuss the numerical based on Kohlrausch law of independent migration of ion. Thank you very much.